In this video, we are going to recap the greatest common factor, or for short, GCF. This is something that you have done way back when, but we are going to add in some variables which may be new. So, greatest common factor is something that two or more numbers have in common. So we're going to start with a factor tree, which is kind of going old school. This is something that I'm going to show you. If you decide to use it, use it. If you don't, that's okay. So we have two numbers. We have 20 and we have 30. And when we do a factor tree, we are going to break down what two numbers multiply to give us 20. So we have a couple of options. We could do 2 and 10, 4 and 5, 1 and 20, although that would kind of be redundant. So I'm going to just stick with 2 and 10. So I'm going to factor out my 20 by saying, okay, 20 is the same thing as 2 times 10. Since I factored out my 20, I'm going to cross that out. That way I'm not looking at that number again. So from here, 2 is prime, cannot break 2 down any further. But 10, we can break down to 2 times 5. So since the 10 got broken down, I'm going to cross that out as well. So what we have is called a prime factorization of 20. So instead of the number 20, we're going to take our 2, and our 5. I'm just going to write it over here. So 2 times 2 times 5. That is our 20, because 2 times 2 is 4. 4 times 5 is 20. So do the same thing with 30. We're going to break it down to its prime numbers. So 30, we could do 2 and 15, 3 and 10, 6 and 5. I'm just going to stick with 3 and 10. But again, it does not matter. You could use any of those combinations. 30 I'm going to cross out because I broke that down. So 3 is a prime number, cannot break that down any further. But 10 we can break down to 2 and 5. So 30 ends up being 3 times 2 times 5. So now that I broke these down, I want to see what they have in common. So they both have a 2 and they both have a 5. So the GCF, or greatest common factor, is going to be 2 times 5, which will give us the number 10. So doing the factor trees, you can break them down, see what they have in common. If they have two things or more in common, they get multiplied together. Could you have done this and found 10 without doing a factor tree? Yes. If that works for you, then you do that instead. But I know sometimes people struggle with this, so having many options is very helpful. So what we're going to take a look at is the part that may be new, and we're going to throw in some variables. So first thing I'm going to do is I'm going to factor out my 12x. So 12, couple of options. I'm going to just start with 2 and 6. So you could do anything that multiplies to give you 12. So you could use 3 and 4 instead. So 12 I'm crossing out because I broke that down. So we have a 2 and a 6. 2 is prime. 6 we can break down to 2 times 3. So I'm going to cross my 6 out. And now we're done. We factored everything out. So 12x becomes 2 times 2 times 3. And then we're going to bring that x down because that comes down with our number. So 12x we still have because 2 times 2 is 4. 4 times 3 is 12. 12 times x is 12x. So we just kind of rewrote it as a prime number. Let me get rid of that arrow. Alright, so we're going to do the same thing with our 40x squared. Again, thinking what two numbers, whole numbers, would multiply to give us 40. Again, a couple options. I'm going to do 4 and 10. So I'm going to cross my 40 out. 4 I can break down to 2 times 2. So I'm going to cross out my 4. And 10 is 2 times 5. So 40 ends up being 2 times 2 times 2 times 5, and then we have x because it's x squared. So again, you can check 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40. So now we want to see what they have in common. So they have a 2 in common, another 2 in common, and they have an X in common. So the numbers and letters don't have to be lined up for them to be in common. So they have a 2, and an X. Well, 2 times 2 is 4. 4 times X is 4X. So the GCF of 12X and 40X squared is going to be 4X. So the largest number that they both can be divided by is 4, and they both have at least one X in common. All right, let's look at the next example. So we have 18M and 45MN. So 18, again, you can break it down into a couple different scenarios. I'm going to pick 3 and 6, so I cross out my 18. 3 is prime, but 6 we can break down to 2 times 3. So I'm going to cross out my 6. So 18M we can rewrite as 3 times 2 times 3 times M. So 3 times 2 is 6, 6 times 3 is 18, 18 times M is 18M. Now we'll do the same thing with 45. Let's do 5 and 9. 5 is prime. 9 we can break down to 3 and 3. So we end up with 5 times 3 times 3 times M times N. So again, 5 times 3 is 45. Same number, broken down format. All right, now looking to see what they have in common. They have a 3, they have a 3, and they have an M. So a 3 times 3 times M will give us 9M. So the GCF for these two is 9M. They both can be divided by 9. That's the largest number that can go into both of them. And they both have an M in common. All right, so we have one more to try. So 14N and 42N squared. So 14 I can break down to 7 and 2. 7 and 2 are both prime numbers, so that is it. So we have 7 times 2 times N. 42 have a couple different options. First one that comes to my mind is 6 times 7, so I'm going to cross out my 42. 6 we can break down to 2 and 3, and then 7 is prime. So we have 2 times 3 times 7 times N times N. We want to look to see what they have in common. So they have a 2, they have a 7, and they have an N. So if we think about that, they have a 2, a 7, and an N. So the GCF is going to be 14N. So both numbers, the highest number they can be divided into by is 14. And they both have at least one N.